State and prove that Kelvin's theorem on the constancy of circulations. The circulations around any, this is the questions. This questions is very important, and I prove this statement. I just given the statement of Kelvin circulations theory. The circulation around any closed curve of fluid particles moving along with the fluid and remains and acting on a perfect incompressible fluid are conservative. This is Kelvin's theorem on the constancy of circulations. Means it is also denoted that it is the conservative and incompressible fluid are conservative. Perfect on a perfect incompressible fluid are conservatives. Means work done is equals to 0. So I have to prove that work done of the circulations is 0. Then I can easily prove that it is conservative. Means constant force is constant. Constant force. So friends, whatever we see, let us consider the circulation and gamma round a closed curve, like a closed curve and closed circuit C in the fluid flow, and let V equals to V1, V2, V3 be the velocity. The circulation gamma is given as gamma equals to closed integral V dr is equal to Vi dxi, and dr equals to dx1, dx2, dx3 in the directed element of the curve, and d gamma by dt equals to closed integral under the C dt of the Vi dxi, dt into Vi into dxi into dt dxi dt d gamma by dt is equal to, because I derived these portions. Whatever I get, I get this value, and I just derivative this value, because gamma is integral V into dr into Vi dxi according to polar coordinates. Since the region of the integrations is a definite portions of the fluid that is on the circuit C. Now friends, d gamma divided by dt, closed integral dvi and dt, dvi divided by dt into dxi, and whatever you get friends, that I just derivative this portion. I just want to derivatives. These derivatives I have to do. So according to the partial differential equations, I use the method. Which method? I use the product method. Hence product method, you know, we already know the how to do product method. Say so that whatever I will get dvi divided by dt, and now I have to use that v and j. Vj is equal to del vi divided by del xj. So friends, just changing the process into dxj. Sorry, it can be written this way. that vi into ddt, just differentiate just result dxi. So friends, this is my total factor d gamma by dt. Now friends, you see that ddt into dxi, ddt into dxi dvi, and since ddt into dxi represents the rate of equals to rate of the relative relative positions of a fluid particle with respect to its neighborhood. Therefore it is relative velocity of the fluids. So friends, this is the total I want to discuss, that this is dvi. So friends, now I will say that the ddt comma dxi, I can write that relative velocity. So I can write this, it can be written this way: del vi. This question, this work is only for university students, friends, because they I explain only for universities. So friends, it is a del xi into del xj into dxj, because whatever we get, friends, this is the very simple that we are handling with the small element ddt of the dxi dvi is equal to dvi. This is the value of the dvi, and whatever we get ddt of the dxi into del vi into del xj into dxj, this is the dvi, friends. So this is the total you get this value. And now friends, whatever you see, we see that ddt of the dxi. Now we use Euler. Now we can write this way: d gamma divided by dt equals to whatever I can write. You see that I just putting the value of the that value dvi. Very easy, friends. This is totally based on theory, but I just explain only for those for helping and discussions, because discussions grow up our knowledge, and I do never say that I am master, but I try to teach, because teaching is the best way of learning. And dvi divided by dt into dxi, and another is c, and you whatever you will get, we get vi into del vi divided by del x j into d xj. So friends, this is my total work, d gamma by dt. And now Euler's equations. Euler equations we know, very important. Euler equations. Euler equations of motion. Euler equations of motion dvi divided by dt. Fluid mechanics is like a ocean. Fluid mechanics is very ocean like syllabus, and a lot of we have to give effort for this. And this is the basic. I whatever I teach, I teach basic fluid mechanics. 1 by rho comma p, capital P, comma I. This is the total my Euler equation of motions, friends. So Fi, whatever you get, Fi equals to, Fi means the force of the conservative body force. Fi is conservative body force. Conservative body force. Conservative body force equals to Fi equals to minus del V divided by del xi. So minus del Vi is equal to del xi. So equals to minus capital U comma I comma this value. So equals to value this value. This is the values totals, and where U, what is the value? U is a potential energy. U is a potential energy. U is a potential energy. So friends, potential energy or potential final function we can say, because in case in physics it is potential functions. We have the Euler equations in incompressible perfect fluid. In incompressible perfect fluids, I use this formula. I also deduce this formula also, friends. Those who are watch my fluid mechanics work, they can get incompressible perfect fluid as dvi divided by dt. Dvi divided by dt equals to minus U comma I minus 1 by rho capital P comma I. So friends, this is the total formula, and minus capital U plus capital by rho comma I. This is the type, friends. I can say I is the type. I is the type means I is the one of the dimensions, friends. It is the tensor dimensions. We know that one here here we are working with n dimensions. Must remember, friends, here we are working n dimensions. I is one of the type. Type means I dimensions. I just discuss particular one dimensions I. That's why I write this, friends. Very, very simple, friends. And after that consequently the equation 3 becomes equation 3 becomes whatever we get d gamma. I just putting the value d gamma divided by dt equals to minus capital U plus P divided by rho, P divided by rho comma I d xi plus closed integral, and everywhere is my circulation is C. So friends, how can I get this value? Friends, you will see that I just marking out that we get dv by di into these equations, and after that go at first this in here, go at first in here, whatever I establish the formula, this formula friends, dvi by dt and d gamma by dt, dv by dt, and you see that dvi by dt is equal to whatever you see that friends, dvi by dt equals to, we say that u plus p by rho comma I. You see that formula, so that's why I just putting this value, and after that I putting this value I putting, and after that whatever we get vi comma del v. After that we getting that vi del vi comma del xi into dxg. This is the total value friends, and after that whatever we get comma c and d capital U plus this value can be written this way, d capital P by capital rho by rho d plus U 1 by 2 into d v I whole square, dvi whole square into dxg, and now dvi whole square. So friends, I can write this way, and after that I can write this way, that minus, not minus, I can write this way, that d 1 by 2 v I whole square minus capital U minus P by rho is equal to 0 is a single valued functions, because since since half small v I whole square minus capital U minus P by capital rho is a single valued function where C is a closed curve. So friends, according to the Kelvin's calculus theory, gamma equals to 0. So I have proved gamma equals to 0. Gamma is equal to constant. Constant means conservative. Gamma is equal to constant means force are. It is the proof that incompressible fluid, this is the proof that a perfect incompressible fluid, are constant. So thank you for watching, friends. So today's proof is very interesting and very important for every mathematics and physics students, and it is including in applied mathematics. Thank you.